Okay, so we're going to do a between subjects, between participants or independent groups t-test here, which is a between participants t-test. If you looked at the web screencast on finding outliers and dealing with outliers, then you'll probably recognize this data here. In fact, I'm just doing this screencast immediately after doing the creating the z-scores, but I've deleted the z-scores here because they were causing a bit of clutter. Now, if you've seen that screencast, you'll know that we found an outlier which was less than 3.29, which is how we determine the significance. But there's a significant outlier at the p less than 0.001 level. We found it was a significant outlier, and we need to deal with that. If you don't know what I'm talking about, have a look at the screencast on outliers, and you'll see these data here. The outlier was actually this one at the bottom, number 40. After a bit of jigging about and messing about with, you've seen that screencast, you know what I mean. And this one was lower than 3.29 standard deviations below the mean. It's bigger than that, if you see what I mean. It was a small number, but the gap was bigger. So what we've done after identifying that as an outlier, we simply replaced that value, which was I think 8.5, with 29. Why 29? Well, if you look on the stuff about outliers, that's the one lower than the next lowest number. Okay, so anyway, let's have a look at this. Let's go to, in fact, I'll just check that. No, actually, I'm incorrect. The lowest number is 31, so this needs to be, let's just 30. Let's make sure everything is present and correct there. We don't make any mistakes. Everybody makes mistakes, as we'll see in 1 second. So what we want to do a t-test is we, first of all, want to find where the t-test is, and we want to compare means. Now, if you've seen the screencast on Boxplots, you remember that what I did was a thing called split the file, and I'll show you that later. It's important, if you've been doing things like splitting a file, to remember when you go back to do a test sometimes, if appropriate, to unsplit the file, because it can cause problems. So again, if you don't care about splitting the file, you can skip this, but if it's worth remembering, if you've ever split the file, to ask yourself, do I need to unsplit the file again? And we do. So what we need to do is analyze cases, do not create groups. I actually, for some reason, like to completely get rid of that and then say analyze cases, do not create groups, and then we can click OK. If you have compare groups selected here and nothing in this box, it won't let you click OK. So analyze cases, do not create groups, like that. So now we've unsplit the files. If you just entered these data straight ahead and not bothered doing box plots and z-scores, then, which you probably shouldn't do, you should always test for box plots before you can test whether to do for outliers before you do a t-test. If you haven't done that, then you wouldn't need to go through that initial step there of splitting the file. It's just because I've been creating z-scores and things to determine outliers. So anyway, back to t-test. T-test, we've got a between participants design here, and t-test, remember, is a parametric way of determining the difference between the two means. Are the two means significantly different from one another? So analyze, which is where most of these tests are, we go to compare means, that's what we want to do, and we want to find the independent samples t-test, independent samples t-test, independent groups t-test, between participants t-test, etc. all mean the same thing. As usual, SPSS has a slightly different name for it, and we get this box here. Now, I will reset this because I've already done the t-test. So what we have here is we have a dialog box with our variables in here, our dv, which is the time taken to perform the task. The study is looking at whether participants perform significantly different on a particular task in terms of seconds, depending on whether they've taken caffeine or a placebo in a placebo condition. So our test variable, the variable we want to test, is our dv. We want to look at that, that's what we want to test, the difference between that. Now this other thing here is a grouping variable. Now this relates to when we set up the data, we would have had to create a grouping variable. And if we let's just go back, actually, I did this on the box plot one, check what the numbers are. So in the values here, which is our grouping variable, we've used 0 for placebo and 1 for caffeine. So we need to put those numbers in this box. So time is our test variable, and our grouping variable is in here. Now again, it's not letting you click OK because it needs to know what numbers you've used. I don't know why SPSS can't work it out for itself. The numbers are in there, but we can define groups. Group 1 is 0 and group 2 is 1. Group 1 is, there we go, like that. And then we simply click OK. These options don't really tend to do very much that's particularly helpful or interesting. So let's click and look at the t-test. So here we've got our means, so it gives you descriptives free of charge, which is quite good for SPSS. You don't actually ask for them. We can see there's 20 participants in this group, the mean of 40.4. There's 20 participants in the caffeine group with a slightly lower mean of 37.3. The standard deviation, slightly bigger standard deviation for the placebo group than the caffeine group, but not massive, and so on. And the question we're asking is, given these standard deviations here, is 40.4 significantly interesting? Is it significantly bigger? Is it interestingly bigger than 37.3? Because you get, differences between means just due to random fluctuations, and it could just be that this is a random fluctuation. So this is what the t-test tells us. So the t-test has a particular assumption. We know that one of the assumptions of a t-test is that the data must meet parametric assumptions. The data needs to be interval or ratio level. It's pretty obvious. The data need to be not skewed, and the data need to have no massive outliers. We've already dealt with outliers, so the data are okay on those terms. The other assumption that t-test makes is that the variation, or the standard deviations, if you like, the dispersion of the two groups is approximately the same. Okay, if one group has got a whopping variation, which would be revealed by a big standard deviation, then the other one, then it suggests that we can't use a t-test properly, and it has to do a little adjustment. So this is a thing called Levene's test for equality of variances. Variance is just a measure of spread, just like standard deviation is. In fact, it's related to standard deviation. It's actually if you like, the standard deviation is the square root of variance, if you care. And we can see that this test is non-significant, right? The significance here, 0.589, is not a significant difference, right? This means, not surprisingly, this 5 and this 3 are about the same. They're similar enough for us to do a proper t-test, okay? I mentioned they are relatively similar. If that deviation at the top, say for placebo, was 10, and the standard deviation for caffeine was 2, then almost certainly this test would come out significant. And what that means is the particular version of t-test that you use, whether this is not significant, determines the particular version of t-test that you use, the particular one you read. So if this is significant, so if this sig here is, for Levene's test, is less than 0.5, we have to use this corrected version at the bottom here. Equal variance is not assumed. If this test is non-significant, as it is here, then we say there is no significant difference between the variances. Remember, that's just the square of a standard deviation, so they're very closely related. So it's permissible to use this top level of t-test here. So we can see that we've got a t-value of 2.1, 38 degrees of freedom, that's simply the number of participants minus 2. And here we've got a significant difference, 0.039. It's less than 0.05. So it's legitimate to say that yeah, the caffeine group do seem to be performing a task more quickly than the placebo group, and that difference is significant at the p is less than 0.05 level. If you go back to the website, it does show you how to report those statistics in terms of writing them out to APA standard.